Hi, my name is Mike Holt, and I'm with MikeHolt.com. And we're going to do a 1 hour program about that time, maybe 55 minutes or so, covering some questions that were submitted to me. Some pretty cool questions. We're going to have a great time. Brian, let me know when I can get moving on the program. Okay, I got Brian House, and I got Mario Valdez, and I got Mike Corwith, my graphic designer. Mario is an inspector. I got Dan Hash. He works for me. A lot of team members behind me here on this team here. All right, let's get going. First thing, I just want to say today is Thursday, April the 9th, 2020. MikeHolt.com/live is the best way to watch this, live that is. And I want to take a moment just to thank God for the blessings that I have. And hopefully, you've gotten some great blessings and that you can appreciate what we have. Listen, we all can complain about first world problems. We wish everything was perfect. But in reality, we got it pretty good here. All right. First question has to do with transformer wiring. I would like you to review what is required by the code. Ooh, I should capitalize that word C on code. And what is allowed by the code, messed up again, for the installation of transformers. So they want me to cover transformer installation. Example, is flex not required but allowed? I guess it should say, is flex allowed? The answer is any wiring method is permitted for a transformer, just like it would be for any application. You don't have to use flex, but you can if you want to. And I'll give you some examples. Bring up points of the pros of using conduit. I can't think of any of those. I mean, can't imagine why you use conduit. What about bonding bushings? Maybe they be required, but not always. Okay, so these are the kind of questions. So let's get into the material. All right, let's just ignore the heading as far as 240.21c3, which has to do with transformer secondary conductor rules. So we're not going to get into that. We're just going to focus on the meat of the graphic. Here we go. You have primary protection device, primary conductors, and then you have a raceway. What kind of raceway can you use? Doesn't really matter. People probably use flex more often than not, because usually the primary protection is pretty close to the transformer. And that being the case, a little piece of flex right there is a great way. But if the transformer is further away, well, you're not going to run flex. Now, there's no code rule that tells you the length of flex metal conduit. You just run it wherever you want to run it. And now you have primary conductors coming in. The grounding and bonding requirements of transformers is contained in 250.30, beyond the scope of this program to cover a 1 hour program trying to cover a lot of rules. So that's not going to happen. But if you're looking about transformers, grounding and bonding, then, get my grounding and bonding program, the books, as the book in the video. What else we have here? We have plastic bushings. No, they don't have to be. We need insulating. We need to protect the conductors. Oftentimes it's going to be plastic. We'll be talking about that as the video goes along. Any pros of running a conduit? Listen, you run flex when flex is a good idea. You run AMT when it's a good idea. You run rigid when it's a good idea. You run PVC when it's a good idea. So the code doesn't tell you what kind of wiring methods in general, unless you get into some special applications. Possibly something is going to be in Chapter 5 or Chapter 6 that might require specific wire methods. But in general, they're wire methods. It doesn't. You can run MC cables. Matter of fact, Mike Corwith, I'd like to add an example here where we run MC cable both to the primary and run to a secondary in some of our graphics. All right. What are some of the rules on transformers? Well, 450.10b tells us a terminal bar for grounding and bonding connections must be installed and bonded to the inside of the transformer enclosure. Probably today, if not all transformers, we're going to be getting there. They're going to come with an equipment grounding terminal bar built in, or maybe as a kit or as an add-on. In the past, electricians had to drill a hole and get an equipment grounding bar and put it in there and maybe grind off some of the paint that was on there, 250.12 about making a good electrical connection. Talking about 250.12. Everything I'm covering here is going to be based on the 2020 NEC, but you need to go into your book. If you're in the 17 code, go in the 17 book code, anyhow, the code references I give you, and then you might see what the slight change is between what I'm saying, or the 14 or the 8 or the 11. As you get further behind, it's not likely going to be the same as what I'm covering. All right, back over here to this graphic. So transformers are going to require to have an equipment grounding terminal bar installed within that transformer. And you can see right here, there was an equipment grounding conductor in the raceway with a plastic bushing, because if conductors are 4 gauge and larger, then you're going to have to provide some kind of protection for the conductors. And more than likely that was flex, so therefore they ran an equipment grounding conductor within the flex, and it connects right here to this grounding bar. The grounding electroconductor is located right here, and this is a fantastic way of having the identifications. And you can see that's connected to the grounding bar. Now, the grounding electroconductor is not required to be green. It could be black, it could be bare. There is no color. You just do whatever you want to do with that. People know what it is. And then you can see that the primary conductors are smaller than the secondary conductors, because in this case, the primary voltage is higher. At the same amount of power, if the voltage higher, current is lower. And then if you have the same amount of power and you lower the voltage, well, then the current's going to be higher. These are all fundamentals that's going to be covered in electrical theory. So we can see what's going on here. By the way, you see these little, I think they call these like identification marks or something like that, or signature marks. What this is supposed to represent is that this person complies with 110.14d, which requires all terminals to be torqued according to the instructions supplied by the manufacturer. And by putting that little witness mark there, of course, you can just do that anyhow, because I don't have a torquing tool. Mike said, put those on there, and that gives the impression that we actually did torque. Nobody's asked me a question about details on torquing, so I'm not going to be getting into 110.14d. So then the secondary conductors are larger because it's going to be a lower voltage and the same amount of power. And there's an equipment grounding conductor run around here, and it comes right in there into that terminal bar. So doesn't matter the wiring methods that you bring on the primary, doesn't matter the wiring methods you bring on the secondary. If you require an equipment grounding conductor in those raceways, fine. If you ran a metal raceway such as EMT or rigid or another type of raceway where it self-qualifies as an equipment grounding conductor, then you would need an equipment grounding conductor within the wiring method itself. All right, sorry about that. I didn't change the batteries because I thought they were good for more than an hour. Now I know. We're going to get a power to that. Okay, back on New York City. Local 3. I went to the electrical training center there, and I took some pictures of the transformers in the training center, and they show bonding bushings and bonding jumpers. And I'm trying to be a nice guy. I'm like, guys, you don't need those. Oh yeah, you got to put the bonding bushings and bonding jumpers. I'm like, no, you really don't. And I'm trying to get the world to understand what the requirements are. There are requirements for bonding bushings and bonding jumpers, but not on the primary or the secondary of a transformer for the raceway system. So if you're at Local 3, talk to those guys out there, and if they think I'm wrong, I'm going to be here every night for a while. We'll be doing this for the next few weeks. Have them give you a code roll. Get it out of the program because you're making people confused. But I love Local 3. All right, back to our graphic here. No bonding bushings, no bonding jumpers. Everything is fine. It doesn't matter the wiring method that you're using. And of course, there's the equipment grounding conductor bar that's required by 250.10a. I want to show you something. I just had this changed. This was my graphic that actually is published in my book. It's the book of Understanding the National Electrical Code, Volume 1, 250.1 scope. Look what I show here. Can you believe that? Bonding bushings and bonding jumpers. I was so excited about this graphic that I gave it to my graphic guy, Mike Colberth, and he made a nice graphic. Article 250. What's the scope of Article 250? Well, it's transformers. Unfortunately, now that's not a code violation, but that kind of gives the impression well, look at Mike Holt's book. He shows bonding bushings and bonding jumpers. But just tell him, he screwed up. I don't want to show something that's not required. And you can see this is flex. That's fine. That's flex. That's fine. Listen, you don't put flex to a transformer because of vibration. You put flex to a transformer or a cable because that's the easiest way to do it. Conductive bending radius. Another New York City story. Nothing to do with Local 3. Is there an NEC or manufacturer requirement to limit conductive bending radius? Nope. Let's take a look at this illustration. It's beautiful. You can see the conductors are coming down. And, these are, I don't know what size they might be 500 thousandths, some of these. Looks like these might be 500 thousandths. So you can see there's a bending radius, whatever that radius is, in order to get right here, to get that insulation. Take a look at this one. This was an installation in New York City, and the engineer on the project said, you can't do that. I want you to take all of the wires that you bent, and I want you to replace all the wire because that wire is defected. Because there is a requirement of a minimum bending radius. Well, there is no requirement of a minimum bending radius of a conductor in the National Electric Code. So now, here's a letter from Southwire that was involved in this whole story. And here's what it says from Southwire. The minimum bending radius for Southwire, and it gives you the wire size, is as follows. 4 times the overall diameter of the cable for 1 inch or less, 5 times the overall diameter for cables larger than 1 inch, but not more than 2 inches. 6 times the diameter for conductors larger than 2 inches, which is a pretty big conductor. Therefore, there was an example in this case here. A 600 kcml conductor has an outer diameter of 1.024, which falls into 1 inch and larger, requires 5 times, and so therefore the bending radius is going to be 5.12. Now, this is what Southwire is saying in this letter that was sent to the engineer. Now, this was just another thing for the engineer. Say, I think it's a problem. He got with Southwire to send him this letter. More than likely, Southwire probably wouldn't send this letter out again because they're given the impression that they have a requirement, and Southwire doesn't really have a requirement. They have a recommendation in their applications guide. So the contractor, I don't know how many tens of thousands of dollars it's going to cost this contract, or it cost the contractor. So now it's in litigation. So even though there is no bending requirement in the National Code, there are some engineers that are out there, and in this case, Southwire happened to send them a letter saying, yeah, no, we have a minimum bending requirement. And so it's an issue. So, and by the way, these conductors were simply bent by a Greenlee bender. I mean, if you look at some industrial control panels, a lot of times you'll see wiring is already in there. Of course, they use a hydraulic bender to bend those conductors. There's nothing wrong with that. So hopefully that will help you out. At least know. All right. Pool pump motor receptacle. And by the way, if you have any questions, please go to mikeholt.com/live, and that's where you post them. And I have 3 people that are right now listening and watching that's going to be feeding me questions right through there. So don't be asking any questions on Instagram because I won't see them and I won't be able to respond. And I don't want to be disrespectful, but I need you to know how the system works. All right, pool pump motor receptacle. The pool receptacle in cord end has been changed over the past few code cycles. That's true. In other words, you have a pool, you have a pool motor. This is mostly going to be in locations where they're going to be winterizing the swimming pool. So they're going to take the pump motor out and they're going to remove it. And then, of course, what is it? Memorial Day, Labor Day, however that whole thing works out. They bring the motor out, they bring the motor back. So therefore, this is the rule about that receptacle and the cord attachment, the attachment plug that's going to be connected into that receptacle. I thought let's go. The pool receptacle and cord end has changed over the past few code cycles. I thought when a twist lock was required, it made a lot of sense to ensure good connection, assuming people twisted the end in the receptacle. Really? By the way, twist lock receptacles are no longer required in the code, not in the 17 or the 20. Why does it have to be a single receptacle? In our area, for a while, the single weather-resistant, tamper-resistant receptacle was not available. In other words, see, if you are in a wet location, outdoors, it would be a wet location. I don't know the exact rule now. We're talking about receptacles 406, that probably 9-ish, 9A, B right in there, says that receptacles installed in a wet and a damp location have to be weather resistant. And then we go over to, 406.12, and you guys will get me the information if I'm wrong there, but I think it's about 406.12 talks about tamper-resistant receptacles and a dwelling unit. So a receptacle that's outside of a dwelling unit has to be, okay, I get the comments, I'm correct on those references. The outside receptacle has to be GFCI protected, 210.8A. It has to be weather resistant, 406.9, probably A and B. It has to be tamper resistant, 406.12. Guess what? They don't make a single receptacle that's twist lock and all those other configurations, and they don't probably even make it today a single receptacle that meets all those conditions also. So the code in the 17 code, as well as the 20 code, didn't make a change there, or they made a change in 17. It says that a single receptacle is not required. Well, that makes it a lot easier. Now, here's what this guy was having to do, though, to make that compliance. He goes, in our area, for a while, the single weather-resistant, tamper-resistant receptacle is not available. To be creative, we used a weather-resistant, tamper-resistant duplex receptacle and cut the tab so only one outlet had power. Well, see, single receptacle is no longer required. So that solves that problem. The tamper resistant was removed, so that solves that problem. So here's what the code is. Receptacles directly related to the circulation system must be located at least 6 feet from the inside walls of a pool and have GFCI protection. Well, there you go. And you notice this receptacle is a duplex. You can put a single receptacle if you want to. I don't know if they make single, we'll have to get research to find out if we make but the next recording we can answer that. Do they make a single receptacle that is weather resistant, tamper resistant? I don't know. But put a duplex. Who cares? Just put a duplex. You got it in your truck, and sit there and screw around special order receptacle. But the key here is the receptacle cannot be any closer than 6 feet from the water. Okay, I get comments that they actually do make it. Well, still wouldn't use it because I'm sure that probably costs 5 times more than a duplex receptacle. I'll have to find out what the cost is. And now the person is commenting, telling me, hey, to me, installing a duplex receptacle of the GFCI type at the pool pump motor makes more sense. I agree, especially since a convenient receptacle can be installed at the same distance as the pump one. In other words, the code says no receptacle can be within 6 feet of a swimming pool. But that receptacle that's further than 6 feet away can be a duplex receptacle. So the question, I don't understand, what are all the changes? Well, all the changes is because the person was describing all the problems he has. And so therefore, a duplex receptacle, it has to be GFCI protected. It does not have to be a GFCI receptacle. It has to be weather resistant, tamper resistant. It's going to have the cover. What rule is the cover? Let's see. The cover would be, it's going to be the same rule. It's going to be 406.9. It talks about the weather resistant, talks about the type of cover, the in-use cover. And that's all I got. And if I don't get any questions, MikeHolt.com/live is where you watch it and where you post questions. We're good now? Brian? Okay, we got some questions. I'm ready. Okay, a comment was, Mike, what about 312.6? There is no rule in 312.6 about wire bending. So if you take a look at 312.6a, it's talking about the distance from where the terminal is, depending upon whether you're coming in opposite the entry or whether you're coming in. So if you're coming in from the top and going right into a terminal, 312.6a tells you how far can that terminal be from that enclosure. Pretty much this is done by the manufacturers, but there are times that you might be putting a terminal and you got to make sure you have enough space so that you have enough space to bend the conductors. But 312.6a is not talking about the radius of the conductor bends. It's talking about the distance of the terminals to the enclosure. So no. Anything else? Here's an example. 312.6a is talking about from this point to this point right here. What else? Okay, that's it for now. Let's move on to the next question. Boat lift, GFCI protection. Here's an example. This is in West Palm Beach. Actually, it's my daughter lives there in West Palm Beach. And I was riding with her on a bike ride. I'm like, there's a boat lift picture. That is the coolest picture. I actually wanted some of the pictures pictures the other side, but I couldn't find a rule to apply it to, so I got rid of them. Okay, GFCI protection is required for a boat lift installed at dwelling unit docking facilities not exceeding 200 volts, 240 volts. In other words, it doesn't matter how many amps. If it's 120, if it's 240, if it's 120, if it's 208 or 240, and it's a boat lift at a dwelling unit docking facility. What does that mean? That means that you could live in a condo like this right here on the ocean, on the intercoastal, and they might have individual possible slips with boat lifts for some of the people that live there. Well, that is a dwelling unit docking facility. So anytime an individual has their own personal boat lift, the wiring going out to that boat lift is required for a boat lift. Okay, it doesn't have to be the wiring. It has to be the boat lift, has to be GFCI protected. So now, here's the question. By the way, Instagram, I am not reading any of your comments. If anybody has any comments on Instagram, you need to go to mikeholt.com/live. I can't read them while I'm doing my program. Okay, he says, Mike, we just completed the installation of power to a dock. We installed a 20 ampere 120 volt GFCI protected circuit for the lights and receptacles, and a 30 ampere 240 volt GFCI protected circuit for the boat lift. The boat lift has internal GFCI protection. I didn't know that. Our GFCI breaker at the source trips when the lift's GFCI protection is part of the circuit. So in other words, you get GFCI protection, I guess the breaker. They ran wires, 30 amps, 240 volts. They connected the boat lift. The boat lift has internal GFCI protection. I did not know that. And he says, hey, my GFCI is tripping. And he goes on. We tested our wiring by disconnecting the lift connection on our circuit holds. The installer of the lift says they have this issue all the time, and what they do is they just install the standard breaker at the source. I disagree with this procedure because the circuit will not be GFCI protected, which could create an electric shock hazard. I have informed the owners of the property of this possible hazard. And I'm not sure where I'm getting the audio. Oh, you know where I'm getting the audio? I'm getting the audio from my computer. Make a note to myself. Turn the audio off your computer. All right, so listen. The NEC requires GFCI protection for the boat lift. And I'd have to take a look at the language of the code, and I might be wrong. You know what? Let's just take a look at that right now. That rule is 555.9. I would have thought, but you know what? Sometimes I think I know something, and I'm like, wow, I was always wrong for 40 years. So let's get your code book out. Let's go to 555. Okay, it's 555.9 in the 2020 code, but they really changed the numbering systems. So here's what it says. So I'm going to read to you what it says. Now, there's no change between the 17 and 20, just that it's relocated, or it's located at a different location. GFCI protection for personnel shall be provided for outlets not exceeding 240 volts that supply a boat hoist installed at a dwelling unit docking facility. Let me tell you something. The number one definition that gets everybody, including me, is the word outlet. Article 100 definition. Let me give you an example of what an outlet is. An outlet is where you receive the point of connection. So where the boat lift is being connected to, that is an outlet. And here's what it says. Let me read it again. It says, GFCI protection for personnel shall be provided for the outlet. So the outlet has to have GFCI protection, which means what? You have to have GFCI protection at the beginning of the circuit. So the entire circuit has to be GFCI protected so that when the boat makes a connection to the conductors, wherever it is, it could be in a disconnect. Well, that's still an outlet. So we got that worked out. So no, you can't take the GFCI protection at the circuit. So now what do, Mike? You know, all the stuff you're doing great, but we're electricians out there and people yelling and screaming at us. You know what you do? you know your code book. You understand electrical theory. Your job, whether you're an apprentice, electrician, inspector, contractor, engineer, instructor, is to make sure it's safe. These people don't understand what's going on. And if you're like, well, I don't know, I guess that's okay. And let me tell you what Mike Holt's going to do. Oh no, that GFCI is staying and that circuit is going to stay there. I don't know what the heck's going on with your equipment, and I don't really care. Because the code doesn't care if it works. The code cares that it's safe. And there's no way that I'm going to be taking away the protection that's required by the NEC. You stand by your guns. You tell them, just get rid of your GFCI protection. Probably that equipment is not listed, because it's highly unlikely that listed equipment would be tripping a GFCI protection device. Why would that GFCI protection device be tripping anyhow? You know why? Probably take an ohm meter or continuity and go neutral to ground. I mean, disconnect all the wires, So now you're just going to go to the boat lift itself, just new to the ground, set it to continuity, and you're going to hear bing. You know what that means? That inside that equipment is a new to the ground connection. Guess what? GFCIs are looking for what? New to the ground connection, and it's going to trip every single time. So you can prove to the person there's a problem, but you know what? The person didn't learn GFCIs. And this is where you learn about how do they work, how does it work out, the wiring, tripping like that. They don't know that. And you just say, listen, I don't really care. I'm not changing it. And you send a letter to the owner in the event that somebody changed it. You say, hey, listen, you've lost the GFCI protection. They removed it. It is a hazard. And you don't just make like a simple little comment on that, because if somebody gets killed because somebody does not have GFCI protection, they're going to just absolutely sue you. So you make sure it isn't like, I think maybe you should. No, it's like you have a hazard. Do not use your boat lift. That is a hazard. You're done. So no, that's the deal on that one. And I'm sticking with it. Next one. How many MC cables can you bundle together? I don't think we talked about bundling of MC cables. We talked about bundling of NM cable. And we went that twice because I didn't do the best job on the first time. All right, so here's the rule. 310.15C1D. Now in the 2020 code, it's moved around a little bit because Article 310 was completely reorganized in the 2020 NEC. You want to know why? Because Article 310 had the information about conductors, and they had conductors under 1,000 volts and conductors over 1,000 volts. And people are saying you have so much information in Article 310 that it confuses people when it's under 1,000 volts. So can you do us a favor? Can you get all the over 1,000 volt information out of 310? They said, good idea. So they moved all the over 1,000 volt information in the 2020 code, and they made it into an Article 311 that I can purposely ignore, because the scope of all my programs is 1,000 volt systems and less. So now when they pulled everything out of 310, I'll say, okay, well, now what are they going to do with all the stuff? Then they started moving it around and sorting it around and changing it all around. And so when I get to 310, I try to give you code references, but I can't remember between 17 and 20. I'm confused. That one especially. All right, so wherever it is, 310.15C1D from the 2020 code in the 17 code, it's still there. It's an exception. Well, here's the rule. Here's what it says. And pass adjustment does not apply to type AC or MC cables when the cables have no outer jacket. You're not going to be putting an outer jacket MC cable and bundling them, but if you did, then you can't apply this rule. Each cable has no more than 3 current carrying conductors. Okay, so you could have 3 phases and a neutral, multi-wire branch circuit, and the neutral's not current carrying. We talked about that in the last video. So that means all MC cables, well, 3 conductor, well, you could have 4 conductor MC, but let's say we got 3 conductor MC. Conductors are 12 gauge and larger, copper. Okay. And there's no more than 20 current carrying conductors bundled together. That means they're all kind of like, they're bundled together for more than 24 inches without maintaining spacing. Not more than 20 current carrying conductors. And if you have a hot and neutral, that's 2 conductors. If you have 2 hots and a neutral, that's going to be 2 conductors because the neutral's not included. If you have 3 hots and a neutral, well, then that's 3 conductors. So you have to do the math and how many wires are in each one. But if it's more than 20, okay, then that ampacity adjustment table that's just before, actually it's in Actually, it's in this rule on 310.15C1 has a table there, and then you'd have to buy it. And we learned in the NM cable that if you go over 10 conductors without maintaining spacing, whether it be cables or conductors, and now AC cable, then if you had more than 10 conductors, it's going to be a 50% adjustment factor. Then you're not going to be able to use 12 gauge wire on a 20 amp breaker because it's 50% of 30 amperes. Because you use a 90 degree C, it's not going to work. This is saying, hey, listen, you don't know more than 20 current carrying conductors, an MC or AC cable, a 12 gauge wire, however you're going to count the number of conductors, you're good. Forget about the adjustment factor. But what happens if you go over 20 conductors that are going to be not maintaining spacing in the cables? Well, it tells you this, hey, if it's more than 20 conductors, you don't maintain 24 inches of separation, then you use a 60% adjustment factor. I was trying to figure out last night, I think it was last night, why on the first night, why I couldn't remember the 60%, because we went from 70% from up to 9 conductors, then we went to 50%, and I thought it was going to be 60%, and this is where that 60% came from. All right, so now here's an example. If more than 10 cables are bundled, and I really shouldn't say it, I don't think it says 10 cables, does it? No, so I have to change my text. When more than the graphic, okay, when more than 20 current conductors don't maintain separation, I think that's correct. They don't maintain separation. Whatever. If that's wrong, we'll fix the text there. Okay, so if more than 10 cables are bundled together, I should say if more than 20 current carrying conductors in cables are bundled together, the ampacity of 12 gauge wire, which is at 30 amperes at 90 degrees C, is going to be at 60%. And 60% of 30 ampere wire is going to be 18 amperes. And you can put 18 ampere wire on a 20 amp breaker in accordance with 240.4b. 244b says this: if the ampacity of a conductor, and by the way, I'm giving you all these code rules. When you go back and you watch this video again, and it's only going to be up for, I don't know how long, a week, a few days, I'm not sure. Watch this video again, get your code book out, and highlight it and mark it. And by the way, Instagram, I can't answer any of your questions and I can't see your comments because I'm working. So post it at mike@mikeholt.com/live. All right, so I have a 12 gauge wire rated 30 amperes. I got more than 20 current carrying conductors that are bundled together. I have to use a 60% adjustment factor at the 30 amperes. It gives me 18 amp wire. I go to 240.4b. It says, hey, if the ampacity of your wire doesn't correspond to the standard size, you can go up to the next standard size. So an 18 amp wire can be protected by a 20 amp breaker, but you got to be sure you read those rules. And it says this: as long as you're not supplying receptacles. Oh, so I have an 18 amp wire. Yep, you do. We bundle all the MC cables, that's fine. And I can put it on a 20 amp breaker. Yep, no problem there. As long as I don't supply receptacles, then I'm good. Correct. Why? Well, Mike, I don't understand. What's going on? Why does it matter? So, see, if you're supplying a lighting load and you calculate the load, you know what the load's going to be. But if you have receptacles, you don't know what the load's going to be on the receptacles, so you can't allow the next size up rule on a circuit supplying receptacles, only on when it's supplying equipment or lighting or whatever the case may be like that. So 18 amp wire now means that you can load it up to 18 amps if it's non-continuous and 14.4 amps if it's continuous. I'm not going to describe what is a continuous and non-continuous load because I have a question coming up here. I don't know if it's tonight or if it's going to be when the next recording is going to be, but I know I'm going to be this. Okay, fine, I'll explain what it is. A continuous load is defined in Article 100. That's when the load is on for 3 hours or more. In an office building, you think the lights are on for 3 hours or more? Yes. Well, if they're on for 3 hours or more, well, then you can't put 18 amps on that wire because the wire's rated 80 amp. It's rated 18 amperes. There's a rule. It's 210.19A1 something. And it says, listen, you have to size the wire and you have to size the breaker no less than 125% of the continuous load. Now, we happen to know the wire size and capacity-wise, and we happen to know the breaker. So if you have to size the breaker and the wire at 125% of the continuous load, if you already know the wire and the breaker, then you work the reciprocal of that, which would be 80%, which means that the maximum load on a 20 amp breaker is 80% of that, which is 16 amps. But your wire is only rated 18 amperes, so the maximum load on the 18 ampere wire is 14.4 amperes. So that's why I was saying continuous 14.4, non-continuous 18 amperes on a 20 amp breaker for your MC cables or your AC cables. Doesn't matter how many conductors you bundle, you're going to be good. Oh, look at that on the next slide. What's a continuous load? Hey, I've been doing this now. I've been with ECNM magazine for almost 40 years. I've been teaching for 45 years. Been in the trade, for 50 years. So I've been around. I got good genes. So, I never had anybody ever have a question what a continuous load is. You read Article 100. It's what? It's a load that's on for 3 hours or more. So here's the question I got. The coolest thing I love is I love apprentices. And those of you that are apprentices watching this, listen, you got to pay your dues. There's just a bunch of jerks out there saying a bunch of stuff. And as you go to school, you learn something. You get all excited about this new thing. You go to a job and you try to tell somebody, and they act like you're an idiot. And I find that is probably the thing that bothers me the greatest in this trade, is that almost everybody in the trade is disrespectful to each other. I'm sure they're terribly disrespectful to the women in the industry, because that's just a natural thing of men, which really, really bothers me. And for the young people, when I say young people, you might be 35 years old getting in the trade. So you're a young person as far as I'm concerned. I'm talking about the person that's trying to come in and they're trying to learn. And they get excited and they want to talk to somebody about what they've learned, and they just get a bunch of crap. So those of you that are just getting crap because you're reading your code book, trust me, I know. I was there. I didn't understand it. I just wanted to learn, and I just wanted to get a license, and I just wanted to make money. I just want to take care of my family. And it really bothered me then, and it bothers me now. So those of you that are young people here, just walk away from that, learn Neander, and don't ever talk to them about technical, because they don't want to know, because they know everything already, right? They learned everything 25 years ago. They know everything. What else did they learn? Okay, Mike, I am a current student at a technical college studying electricity. I caught that double space, by the way. My question is about what is considered a continuous load. I'm thinking, all right, seriously? Okay. My instructor says it's a load that is on for 3 hours or more in a 24-hour period, which I take to mean a load that could be on 10 minutes at a time. But if it totals 3 hours or more in 24 hours, it's a continuous load. The code book just says a load where the maximum current is run for 3 hours or more. Does not specify 24 hours. My answer? You're right. Structure's wrong. So all you have to do is go to Article 100 definition. There's nothing in there about a time period. You have a load that goes and it runs for 3 hours or more. At any given time it runs. It maybe runs only twice a year, but it runs for 3 hours or more. Well, then guess what? That's a continuous load. Why is that important? Because when you carry current on a conductor, it ultimately creates heat. The greater the current, it's called I squared R. We covered that in our in theory. Okay. The higher the current, it's I squared, which means you're squaring the current times the resistance, and that's where you're going to get your heat, and it's called power. It's a function of time. In other words, you can get something happen so fast. It's like taking a candle. I'm sure you guys have done this or seen somebody do it. There's a candle and it's lit. Go like this. Look at that. Oh man, you're so... And then you give it to a little 9-year-old kid, particularly a boy. Girls are too smart. Yeah, I don't think so. But a 9-year-old boy. And you say, hey, you want to try it? Now, they don't understand the concept of time, right? You went like this. What are they going to do? They're going to go slower and they're going to get burned. My point is this. Heat is a function of time. So the longer the load is running, things take effect. Just so you know, circuit breakers are not rated to take current for 3 hours or more at its rating. Let me explain this to you. 100 amp breaker. You can put 100 amps on here as long as you don't run it continuously on it. If you run it for 3 hours or more, the breaker is not designed for that application. It's not. It's designed for an application where you don't run it for 3 hours or more. Mike, come on, man. Every single commercial, industrial job, not residential, but pretty much all the loads are continuous. Right. Well, that doesn't make any sense. Well, that's the way it is. So now what does that mean? That means that you have to limit the load on the breaker to 80% of the rating of the breaker so that you can use the breaker. And is that stupid? You would think that you can just buy a breaker that's designed, if it says 100 amps, you can put 100 amps on it, whether it's for 5 minutes or whether it's for 5 hours. That's not the way. Now, do they make a breaker rated for 100% continuous operation? Yes. So if you have a 100 amp breaker and you have 100 amps continuous on a 100% rated breaker, you could size the wire to 100 amps, you could size the breaker to 100 amps, and you can carry 100 amps current on it. But if you don't get a 100% rated breaker, then you have to size the wire, the load rather, to the wire and the load to the breaker to no more than 80% of its rating. Now, we don't use the 80% in the code in reality. What we do is we take the load, as it says in 210.1981, we take the, and also 215. I think it's 2. We take the load at 125%, the size the wire and the size the breaker. So that's what a continuous load is. Modifying listed products. By the way, Instagram, I can't read any of your comments. You need to go to mikeholt.com/live. I apologize because I can't. How about modifying listed products? The question was, what about 100% breakers? I thought I just said that. So the person asked that question, maybe asked that question before I explained it. And that was a 100% rated breaker. You can do what? A 100 amp breaker rated 100%. You could put 100 amps on it, and you can use a 100 amp wire on a 100% rated 100 amp breaker. But since you're not using 100% rated breakers, you're going to put no more than 80 amps on a 100 amp rated breaker and having a 100 amp rated wire. Now watch, if you use 100% rated breakers, you don't have to size the wire and the breaker to 125% of the load. That means you automatically save 25% of the conductor size. And the cost of wire as you increase the conductor size is not linear. In other words, you know, a 12 gauge to a 10 gauge isn't linear, and then 1/0 to 2/0 and 2/0. In other words, so the cost goes up a little bit more than just simply the amps. In other words, a 50 amp circuit, 50 amp wire and a 100 amp wire, it isn't like it's double the cost. So what you would like to do is you'd like to not put any bigger wire than you have to. Well, then do it. Then do this. Get with your gear guys. Say, hey, listen, I want to get 100% rated breakers. So when I run a continuous load, I just go ahead and size the load right to the breaker, and I size the wire right to the breaker. That's a perfect world. So hopefully that, if I didn't do a very good job the first time, hopefully that little second attempt made it a little clearer. Listen, I'm going really, really, really fast here. If you know the code, great. You're like, oh yeah, Mike, check, 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 check. Maybe I'll say a little thing here. But those of you that's an apprentice, this is like, shh, it's okay. Listen, watch this video 3 or 4 times. Get your code book. Go back on it. This is an introduction to many of these rules for those of you that don't have the skills, don't have the practice. And if you're not licensed, you better get yourself licensed. You're an electrician, you're an inspector, you're an engineer. I mean, you don't really license in the industry, you better be licensed. All right, here we go. Modifying listed products. Mike, how much latitude, if any, does the code allow me to modify an electrical fitting, fixture, or component? All right, let's go through a bunch of different code rules, and then I'm going to answer the question, okay? 90.7, examination of equipment for product safety. Except to detect alterations or damage, listed factory installed internal wiring and construction of equipment need not be inspected. In other words, you'll see in a little while, as we cover these things, I'm going to get ahead of myself. If you have a listed product, the inspector is not supposed to be going inside the wiring of a listed product and say, wait a minute now, is that wire spacing from the plug to the enclosure complying with 312.6? Is that wire size right? Is that the right color to use? Are you using the grounding fittings? You're not using sheet metal, in which the inspector does not get internal wiring. Look at this example here. Here's a Generac. I can't remember exactly what this is called. I'm sure somebody will give me a note in my ear here what it's called. But this allows, it's called a generator transfer panel. So you take this wiring here and you connect it to the panel, and what happens is you take wires that were going on a breaker in a panel, now you connect those wires to some of the wires here, and it goes now to the generator transfer panel, so that way it can get power, and then the transfer power goes to these conductors, and then you have conductors going back. So you have wires, let me see, so you're gonna have the wires from the power. Oh, no, yeah, we're gonna have the power there. No, hey, Brian, help me out here. Do I run wires from the panel to the transfer, and then from the transfer it goes back out to the loads, or do I just run from the panel?
That used to be in the existing panel.
So I'm only going to be running wires that was off the breakers in the existing panel. I just connect those to the wires that's going to this generator transfer panel. Right?
Yes.
Okay. So guess what? Well, I don't know how many wires you have in that raceway. What about conductor ampacity adjustment and all these other rules? That's not what the authority having jurisdiction. This is a listed product. Stay out of that. Okay? So that's number one. Just what the authority is on 90.7. And then there's a definition called approved. Now, approved is acceptable to the authority having jurisdiction, and it's usually the electrical inspectors. All right, so back to 110.2, the authority having jurisdiction is one who makes the approval of equipment, and they could allow you to use something that's listed, or they could not allow you to use something as listed. They could allow you to use something that's not listed, or not allow you to use something that's not listed. So we got that started. 110.3b, equipment that is listed, labeled, or both must be installed and used in accordance with any instructions, including in the listing or labeling. So when you buy a product, it's going to have a little book, and it's going to tell you all kinds of information, wire size, breaker size, whatever the case may be, it's going to give you that information. Then you have to follow those instructions. Now, take a look at these conductors. You see right here? And that's called a haircut. Apparently, the wire, I don't know, this looks like, I don't know, I want to say it's 600,000 maybe. The wire was too big to go in. Listen, can you imagine this? This is a pretty big installation. This is some big wire. This isn't like 14 gauge. And they cut the strands off of that. So they're modifying the listing of this product. This wire was never listed to be installed in this manner. Not only that, but when the code requires you a certain conductor size and you start cutting the strands off, what size wire is that? Is that still a 600 kc mils? So this is an example like, okay, but Mike, I understand that one, okay, that's great, but listen, anytime you go into a listed product, you do anything to it, it wasn't identified to be used in that manner, then the listing value is removed. I'm not saying the authority having jurisdiction won't allow you to do it, because there might be some compelling reasons why, and you're going to go to 90.4 and say, hey, you know, this product, I have to violate the listing of this product because this is what I need to do. And they might say, oh, okay, I'm going to be good with that. Okay. So anytime you're modifying products at all, the authority having jurisdiction and one who approves the equipment. So you're going to have to get that person to get it to you. And by the way, they're going to give you that permission. They're going to waive a rule at 90.4, and it's going to have to be in writing. Brian, I think we're going to be done here. Instagram. Oh my gosh, people want me to go over the continuous load. Like I thought I knew that. Apparently it's not that clear. Want me to go back over that. What is a continuous load? Well, let me see if I get here. The book says it's a load where the maximum current is on for 3 hours or more. Put a timer. It ran for 2 hours and 45 minutes. Okay, not continuous load. Put a timer. It ran for 3 hours. Boom, continuous load. So, guys, I'm missing where the complexity is. So help me see something that I'm missing, that I'm thinking it's kind of obvious. Brian, anything else and anybody else's questions? I don't want to start another question because it's going to take me a lot further. All right, those of you who watch this, you need to post your questions at mikeholt.com/live, and I will get those questions. And tomorrow I'll consolidate them, and I'll put them on my batch, and I'll keep going on. And I want to thank you very much for watching this. God bless, be safe, and get your code book. Maybe you need a theory book, maybe you need products, go to mikeholt.com/products, and maybe buy something from me, because if I don't make money, Mike Holt Enterprise are going to have to be gone. All right, God bless. See you later.